All right, it's a yes. So bonding has always been a very, very interesting chapter for me because that is the topic from where I got the interest in chemistry, basically, and that is where I was able to relate the chemistry theories with life. So it's very special, and I teach in the most funniest and easiest possible way I can. If it sounds boring to you, then I'll be very, very sorry. Yeah, with breakups, kind of. Arisha, you're right. Make sure your mics are mute. I do not need to repeat it. Like Hiba Hasib's mic is not mute, so please, if you can do it, then it will be an issue to hear. So let's begin. As far as bonding is concerned, the first objective will be why does element needs to bond? That is the thing which you need to understand. Then is describe how ionic bondings are formed between metals and non-metals. Then is describe how covalent bonds are formed and explanation about the metallic bonding. I would love to cover everything in this one class, but if it doesn't happen, then we can always redo it again. So first is ionic bonding. Ionic bonding are stronger electrostatic force of attraction between positive and negative ions. Ionic bonding, it does happens between metals and non-metals as well. Can you tell me who makes the positive ion and who makes the negative ion between metal and non-metal? Quick answers, please. Ionic bonding is between positive and negative ion, between metals and non-metals. Who makes the positive ion? Who makes the negative ion? Metals make positive ones and non-metals make non-metals will be negative. Amazing. That's right. Hajra, Aksa, Maruk Yusuf, Hamida, Riha, Risha, Sara, Ashmal, Alisha, Shakra, Fatma, Rafiq. Great. Next is loss and gain of electrons happening during ionic bonding. Raima, mute your mic.
Are you being able to see my messages?
Yeah, I can.
Okay.
You can always unmute your mic, and if you want to answer something, you can do that. But the only fear in this is that by 2 or 3 people wants to do it at a time. But of course, you can always try. I don't mind at all. Okay, next is in ionic formation, metals and non-metals are involved. We discussed it very clearly. Explanation of ionic bond with example, and this is the most interesting part. And I'll tell you why. Because here we're going to watch a video, a very cuter one I love the most. Because nothing has been written under the heading Sandaleen. That is why you are unable to see that, which is perfectly alright. Can you see the video? Alright, what can you see on the screen right now? Have you heard the energy in my voice by just looking at this? Yeah, that's right. Let's watch together. I so love it. Quickly tell me who these two birds are in 11S. Now, one is the one who's making the noise, and the other is the one who's shushing that one. So, who can be the one who's making noise and the one who says, "Shush, don't do that"? And who are these two nerds of the class? And the birds are enjoying, and they are solving some kind of a puzzle. So just by looking at this, what comes in your mind? What is the meaning of the bonding? I really need to know your definitions of bonding just by looking at this. One was unable to make the puzzle, the other one helped out in the puzzle completed, and that's what we call a bond. So I'm not interested in typical chemistry definitions. I need to know what comes in your mind. Giving and taking to fulfill needs. Aksa Amin, I loved it. What else? Your definitions, like yours one. One giving itself to other for fulfillment. Fatma Khosu, wow. Part of itself. Medals, health. I really liked it, Fatma. Metals help the non-metals to become stable. Arisha, for once, get out of chemistry and give a definition related to real life. Sacrificing for something for others. Briha, I like it. When two parts are conjoined. Philosophical Sarah. To join together to form something new. Giving part of itself to complete another thing, therefore bonding. Yes, Hajra. Not bad. Creating a link. How precise you are, Manur. Sandalene gives the electron to become stable. Again, Sandalene and Arisha are two into chemistry. When two things are linked together or sharing, yeah, Maruf, we can say that. It could be balanced but when they work together, it was balanced. Wow, Alicia. Completion. Matlab, wow, Maha. Bonding can be one word. I never thought of it, but it's nice. So if you love someone, you are ready to sacrifice something for them. Now you're talking, Arisha. Urusha says, join together and one sacrifice for the new thing to form. That's right. Raima, I can't see your answer, man. Where it is? Where is it? If
Miss,
I
I've
can't,
been typing. If it's
so
five times.
just say it. Just say it. Forget about typing.
Well, bonding is like
Bonding is
combining
like
together to
combining
fulfill
together
the
to fulfill the
requirement.
requirement.
Not bad. Very nice. So you keep on answering me whenever I ask a question because I can't get your chat. Aksa says, turn this into a love story as well. Oh yeah, love stories are always there, but that love stories can be with your mommy, your daddy, your siblings as well, even with your teddy bear. I have a love.
Sacrificing yourself for
Happiness.
happiness.
Oh yeah, that's a kind of a self bond with your own self. Great. So lots of emotional bonding thing happened just right now. Let's move on. Who's the most sleepiest one in our class? Guess.
Me.
Correct. And who's this one? Crying always. Crybaby. After one. So here we got one. I was about to say Raima, this non-metallic atom, the one crying always, but Raima is not like that. She's very, very strong. Anyways, ionic bond is a transfer of electron from a metallic atom to a non-metallic atom, and you can see very well, very clearly a metallic one in front of you, and non-metallic is one. So metallic one, can you see the expressions on this metallic atom? How firm and fearless the person is, and the non-metallic is so worried about something coming up. Who's this one? The most loneliest one, and the other are always teasing this electron, or the valence electron, or the loneliest electron in the class. I want all of you to be with me by keeping your chat boxes updated, because that's how I'll be motivated. All right, we love each other, Ashmal. That's Briha. Why it's always has to be Briha? So sodium has an extra electron in its outermost shell, and it is crying, and it's just because it's not finding out any pair. Yeah, I'm crying. You're being targeted. That was heavy. But yeah, I feel that the people loves you. Like all in the girls in the 11s, they love each other like really good way. So this one is chlorine, and chlorine has the 17 atomic number. Yeah, Raima, do it. Don't worry. Oh. So chlorine has 7 electrons, while sodium has 1 valence electron. That 1 valence electron is not happy with his life. So as in these 7 electrons, something is missing. So let's see. Aksa, I have no idea how to resolve this issue because everybody is able to join. Tell her to click the link given in the WhatsApp, because in one of my device I joined from there and it was very easy. Have you found out the issue in chlorine? Can you tell me what exactly is the issue? Hurry up, quick responses, girls. You have just seen what's happening in chlorine. No partner to, everybody got the partner, but not 1 electron. Yeah, 1 electron is missing a buddy. Exactly. How do you know it's a he, Manur? Yeah, but why do you people think that it's a he? Why can't this electron be a she? Arisha, my question then from you is that is it interesting, or are you able to understand, is the concept being delivered, or do you like the purpose is being filled or not? So that's the important thing, because I feel that, you know, keeping the board on and giving you the concepts, it's monotonous and it sounds boring sometimes. And I miss my 11s fun time. So here we have this one, shocked and missing over a buddy, and here we have 1 electron in sodium as well, which is again the lonely one. And what do you people suggest for both of them? Let's see what happens next. It was a good one to become a family. Did you see this creepy smile and the way he is bribing that electron? So weird. How can someone get bribed over a lollipop? So initially sodium was an atom, and now because, oh my god, Ashmal can be, alright. Sodium was an atom and now becomes an ion, and it becomes a positive ion after donating that one electron. So these creepy smiles tells us that chlorine has accepted an electron from sodium, and again sodium is no more an atom, it becomes an See, this is the uneasiness of a third person when you people are making the bonds, and when we are so happy as one class family, then the other people, how do they feel? I don't want to mention the class over here or the people over here. It's being recorded. Why Sandaleen is so silent, why other people are not saying things, why Fatma Rafiq is not saying, Fatma Khoso is not saying. These are the names like on my fingers who respond very quickly. Urusha, she is not responding. I want responses from everyone. Such thin hands. Not, yeah. Yeah, of course, not from our class, Arisha. Sandaleen, okay, Sandaleen. So get ready for the wrap up. I had your name in my mind. Why do I stop? It's because I wanted you to note it down that oppositely charged sodium and chloride ions are held by a strong electrostatic force of attraction known as ionic bond. And electrostatic force of attraction is the key word. So this was the cutest example I've ever shared with the people, and the moment I shared it, I really enjoy it as well. This is what we call ionic bonding, and now we will see next. Yeah, he dreamed about chemistry. That was another funny thing, like dreaming about chemistry. But I used to do it when I used to study chemistry. Who does dream about chemistry? Yeah, really, Ishmael, that would be really interesting to know what was it about. Raima, it hurts, nightmare. So we did study about ionic bonding, and now we will see the giant lattice structure. Like people are seeing me in the dreams. Anyways, back to work. Back to work. A giant lattice structure is three-dimensional network of ions. Note it down, girls, because when I'll play the video next now, I'll be asking you that where that point leads. All right, Ashmal. That sounds weird. The ionic.
Miss, I can't see the screen.
Okay, you cannot see the screen. Well, I can give you the pointers. You can note it down because quickly we are moving on towards the video then. So these points will automatically be repeated over there. A giant lattice structure is three-dimensional network. So ionic compounds are always have a giant lattice structure. The ions are packed in a regular repeating pattern. They are soluble in water. We all know that. They have high melting and boiling points. Can you quickly tell me that why ionic compounds have high melting and boiling point? The ionic compounds have giant lattice structure. They are packed in a regular and repeating pattern. They are soluble in water, and they have high melting and boiling points. And here my question is that why they have very high melting and boiling points. Okay, Ria says that strong bonds are not easy to break. Fatma Khoso, their bonding is very strong. Maha Adnan, strong electrostatic forces, strong force of attraction. Urusha says strong forces. Manu says they're held together by strong electrostatic force of attraction. All right, the people who are using the term strong electrostatic forces of attraction, they are basically giving me an unbeatable answer, because if you use this word, strong electrostatic force of attraction, it defines everything, because it's a key word. So I would suggest you that whenever they ask you about the ionic bondings, that why they have high melting and boiling points, always use this word, that they have strong electrostatic force of attractions and they are solids. Again, there are things where keywords are really important. Now, the next thing is they do not conduct electricity in solid state. Can you tell me why again? Why are they unable to conduct electricity in the solid state? Very good. Very good. Very good. So I got the answers from Riha. I got the answers Manur, Aksa, Maiba, Risha, Shakra, Raima, Maruk Yusuf, Hamida Maiman. Good. Uh, yes. Yes. So for conduction, we all know that we would be more appropriate ions or electrons. Sarah, see, my question is that why ionic bonds cannot conduct electricity in solid state. So here we are talking about solid. So whatever word you be using, it will appropriate to this particular question. Otherwise, I've always said that when it comes to ionic bonds, use the word ions, and when it comes to metals, use the word electrons. Otherwise, the safer side would be saying that no free particles, because conduction is very much related to the free particles. So if there are no free particles, that means no conduction is possible. It's as simple as that. I hope the thing is clear to you. All right. So let's begin with another exciting thing, the properties of ionic compounds. Let's see how that's going to work.
Do not just exist in a laboratory.
Can you people able to see this video, and are you able to hear it? Like, I hope there are no issues. Okay, great. Let's move.
Laboratory or in your chemistry homework. Sodium chloride is regular table salt. Sodium fluoride is added to some toothpaste.
Now these are some interesting. This is a kind of a serious one, so we'll quickly finish it up so that we can move on to another exciting one, which I really want to see with you all. So ionic compounds. Here are some examples. One is the sodium chloride, and sodium chloride is a table salt. One is the sodium fluoride, and it is used in the paste
to help strengthen tooth enamel. Ammonium nitrate can be used to fertilize plants.
These are three most used kind of ionic compounds. Generally, we do it in our real life, so they are actually connected to the real life examples as well. So you must know this when you will be giving me a wrap up, because you know that I'll ask anyone anytime.
Miss, what is ammonium nitrate used for?
Ammonium nitrate is used in the fertilizers. It is used in fertilizers, and that is to grow the plants.
Life applications are very different. They share a few key properties. In this lesson, we will have very high melting points and are brittle.
So the first thing is that they have very high melting point. That is the first property of ionic
points, and are brittle because of their 3D giant ionic lattice.
Reason why I chose this video to show you, even it's very serious, and I was not in a mood to show you this kind of a serious diagrams, is because this diagram, this giant lattice structure, because nobody else has shown this giant lattice structure so well the way they did it. So please do have a look at it. That's how basically the ionic compounds are, and these giant lattice structures play a very important role in their properties.
Structure. The strong electrostatic attractions holding the 3D lattice.
Hajra, sodium chloride is just a common table salt, the one you regularly use.
Structure in place mean that a lot of energy is required to overcome these attractions. When we apply in place, hold ionic points and
I'm repeating this lattice structure thing again, so understand the importance and listen it carefully.
Brittle because of their 3D giant ionic lattice structure. The strong electrostatic attractions holding the 3D lattice structure in place mean that a lot of energy is required to overcome these attractions. When we apply a force, it breaks the regular repeating pattern of oppositely charged ions, causing ions with like charges to come close to one another. The ensuing repulsion breaks the lattice structure. Sodium chloride, sodium fluoride, and ammonium nitrate can all dissolve in water, as we know.
So the first point was that they have very strong, they have very high melting and boiling point. The other one was they had giant lattice structures and the strong electrostatic force of attraction. And now they're talking about the solubility.
Else we wouldn't be able to flavor our soups, brush our teeth, or fertilize.
So sodium chloride or ammonium nitrate, no matter which the compound is, they all are soluble in water, means all of the ionic compounds can dissolve in water.
Our plants. Most ionic compounds are soluble in water. In water, an ionic compound can dissociate into its ions. So when we dissolve sodium chloride, it will dissociate into sodium and chloride ions.
This is very important. That's how solubility happens. Whenever you are dissolving something and that thing is soluble in water, they basically divide or they spread into their ions.
These ions become stabilized in water due to the polar nature of water.
Now I have a very, very serious question over here, and be careful when you will be answering this. They said that when the ionic compound is dissolved in water, the ions are separated from each other. Can we say that the bond has been broken down completely and the ionic bond is completely broken down? There are many oxides, Ashmal, and there are many other elements which are, they're very complex compounds which are not soluble in water as well, but they are complex compound made up of transition elements generally. Yes, thank you for responding to this question very quickly. Arisha, Aksa, Sara, Fatma Koso, Hajra, Briha, Manal, Sindaleen, Urusha, Alicia, Hamida, Maha, Fatma Rafiq, and Manur. That's right. If the ions dissolve in water, it does not mean the bond had been broken down completely. The electrostatic force of attraction is still there and it's just a physical change, not a chemical change at all.
As you can see, the sodium ions are stabilized by the negative dipole of water, and the chloride ions are stabilized by the positive dipoles of water. This solvation stabilizes the free-floating ions. An ionic compound dissolved in water can conduct electricity. This is another key property of ionic compounds.
The last and the very important point, the ionic compounds does not conduct electricity in solid state, but they can conduct electricity when they dissolve in water, and the reason is, please answer in the chat box quickly.
Compounds. This is made possible due to the presence of free-floating ions.
Manu, right.
We can dissolve copper 2 sulfate in water in a beaker. Add a few drops of sulfuric acid.
Very right.
Place a strip of copper and a strip of zinc into the solution.
Right.
These will act as electrodes. Using 2 alligator clips, connect one.
So I'm not discussing this further because that is the point where I wanted all of you to move on, and that is the ionic compounds. These ionic compounds are their properties, their melting and boiling point. Now we'll quickly move on towards the covalent compounds. Can you all tell me that what do you know about the covalent compounds? How are they? How can we form them?
A covalent bond is formed by the sharing of electrons between two atoms.
Very good, that's right. And here another exciting one. I'm so excited to see it. We'll see how does the covalent bond is formed. Yeah, it formed between non-metals. That's right. I think it's very already been clear that noble gases are the ones which have complete outermost electrons. So Raima, I literally love the way you are. Who can be the neon of the class who's not ready to bond with anyone? See, neon is just not the one who is. All right, Bria. Neon is the one who is just not ready to bond with anyone, but neon is the one who has the universe stability. Everybody looks up to that neon to get that stability which it has, because gaining that stability, it needs a lot of effort, a lot of concentration, a lot of positivity and whatnot. This stability is not easy. So this is another perspective of looking at the diagram. While you were seeing it, you were saying that it's not just bonded with anything else, but from where I see it, it's the most stable one in the universe. And every other element of the periodic table, they try to achieve that stability which the noble gas configurations have. Padma Koso, mark my words, 5 years down the line, just 5 years down the line, you will get to know that being a high achiever will not bring any kind of a stability in your life. It brings you even more in a restless condition. I'm still unable to figure out how can we attain that stability, but let's see. Ajax, I agree to you somehow. No, Bria, you can't be. See how desperately he's looking for stability. Have you seen the countdown of all of these? See, when they were alone, and we used to count their valence electron, that count was 7 each. But now when these electrons has been shared, now see the countdown, like a count of the valence electrons per atom. Now, this central atom will be counted with these central electrons will belong to each one of them. And when we are counting them, these central atoms electrons will be counted. Yeah, so now they got 8 electrons in their outermost shell, and the stability is there for which they were looking for. Now here we are moving ahead towards the types of electrons. So just note it down with the examples. When it comes to chlorine or when it comes to all halides, they share one electron, which forms a single covalent bond only. It's a single pair of electron, like each atom will share one electron. So that is single covalent bond.
Yeah.
Oh.
Listen it carefully. This song is so amazing. More than that, the way he's singing it. Arisha, there is no difference between halogens and halides. It's just that we are taking two names in different languages for one single group, which is group 7. I hope that you like the details, and the details are that this one is an oxygen and it has 6 electrons in its valence shell, and it needs 2 more electrons to complete that octet, which is having 8 electrons in its outermost shell. So he can share 2 electrons with another oxygen. Yeah, right, Aksa. You are seeing it from a very different perspective. I like it. That's Hajra? Yeah, singer. So this is the example of a double covalent bond. When two oxygen atoms come together, they each share 2 electrons to complete their octet. So each atom is sharing 2 electrons. That means 2 pair of electrons has been shared. So that's what we call double covalent. Raima, I love it. This one a cute example of nitrogen in which each nitrogen is sharing 3 electrons each. So means 3 pairs. 3 pairs means in total 6 electrons. So let's count 1, 2, 3, 4, 5, 6 electrons. So when 6 electrons are bonded or there are 3 electrons shared by each atom, this kind of an example of triple covalent bonding. Isn't that funny? All right, so that was the covalent bonding. The covalent bonding between two atoms that happens by sharing of electrons. All right, yes. So the last one, very quickly, 2 minutes more. That is the metallic bonding. Can you see the next screen? Like, is it visible to you all? What's written on that? Just to know that you can see that. What's written on the screen right now? Yeah, that's right. Let's have a quick look.
However, there are only metal ions. These metal ions are arranged side by side in a regular repeating pattern. The free-floating electrons act like a glue and hold the structure in place.
So this is the structure of the metallic bonding, or that's how metallic bonding works. In metals, there are ions which are positive, and there are free electrons moving together, and there's a force of attraction developed between these electrons and these positive ions, and that force of attraction is called as metallic bonding.
This is a very strong attraction and explains why metals have high melting and boiling points.
Whenever there is a force of attraction is between two ions, between two positive charges, that particular thing will always have a very high melting and boiling point.
Heat energy is needed to overcome this attraction.
So that's how this metallic bonds work. In metallic bonding, we had ions, we had sea of electrons. There is a force of attraction between these metals and these sea of electrons, which called metallic bonding, and also it causes the high melting and boiling point as well. So let's move ahead towards the wrap up now, and let's see who is going to help me out. I thought Ashmal just left, but she's there. Okay. Can you see the screen in front of you? And if you can see that, what is it? Yeah, that's right. So now I would request, first of all, starting with Sandaleen. Sandaleen, can you tell me what we begin with today's class? Unmute your mic.
We started with bonding. In which I told you the meaning of bonding is sharing of electrons. And then we did the example of sodium, in which sodium reacts with chlorine to form ionic compound, sodium chloride. Ionic bonding is the transfer of electrons from metallic atom to a non-metallic ion.
Very good.
And sodium has 11 atomic number. Sodium has an extra electron in its outermost shell, and chlorine has 17 atomic number, and the electronic configuration is 287. And and chlorine has 7 in its outermost shell. It needs 1 electron to complete its outermost shell. Sodium has 1 extra electron, so sodium donates one electron, and sodium was an atom. By donating, it became a positive ion. And electrostatic attraction holds the sodium and chloride ion together.
But not bad.
And after that, we did a giant lattice structure. You explain what it is in the video. A giant lattice structure is a 3-dimensional network of ions. The ions are held in place by ionic bonds. And then we did 3 examples. Sodium chloride, which is the table salt. Sodium fluoride, it is used in toothpaste. Ammonium nitrate, it is used as fertilizers to grow plants. High melting boiling point because of their giant lattice structure, ionic structure. Strong forces of attraction is holding the structure in place. Because a lot of energy is required. NaCl, all are soluble in water, but in NaCl dissociates into sodium and chloride ion. Ion becomes stabilized. Ionic compound conduct electricity in water, but not in solid state due to free particles. And then we did covalent bonding.
So much, Sandaleen. Yes, they are soluble in water. Yes, they can conduct electricity only when they are soluble, because they will have free particles. Soluble in water, but not in the molten, not in the solid state. Very good one, Sandaleen. Very, very, very impressive. I really liked it. Since Ashmal have volunteered for the wrap up, and I really appreciate the people who volunteer. So Ashmal, it's your turn now. Tell us about what we have studied after ionic bonding.
After ion bonding, we studied covalent bonding. In covalent bonding, we studied that it's basically when two atoms come together to share electrons to become a molecule, or as we can call it, a covalent bond. So for
Very good.
example, if there's a central pair coming together, which means one atom shares one electron, it'll be known as a single covalent bond. If each atom shares two electrons, it'll be called a double covalent bond, for example, oxygen.
Very
And
good.
if three atoms share three electrons, it'll be called a triple covalent bond, which is nitrogen, for example.
Very good.
At the end, we studied metallic bonding. Metallic bonding is basically when free electrons hold a metallic bond together, and free electrons they provide a very, very strong force of attraction, which can only be overcome after heat energy is provided.
That's awesome. So metallic bonding is basically when these positive ions are arranged in a particular way, and these negative electrons will be all surrounded, and there will be a force of attraction developed between both of them. That's awesome. Thank you so much, Ashmal, for the amazing wrap up. Thank you so much, people, for coming and joining in the class and giving me this amazing time. I hope you enjoyed the class as well. So it's time to go now. Stay safe, stay home, take very, very good care of yourself during Ramzan, especially be hydrated. Take care. See you in the next class, inshallah. Allah Hafiz, everyone.